Now, let's have a look at LDAP in detail.
Before we learn LDAP, let's have a look at the concept called directory service. And quite similar to a file system, a directory service stores and traverses data in a tree-like structure. So naturally, it has different layers. You can regard the address book on the mobile phone as one typical implementation of directory service, which stores and manages the relevant information of different contexts. But there is the question, what is the relationship between LDAP and directory services? Actually, LDAP is just a typical directory service. The full name of LDAP is Lightweight Directory Access Protocol, which runs over TCP/IP or other connection-oriented transfer services. And just as we mentioned before, LDAP serves as the management module as well as the identity storage server for Huawei Cloud, remember? And here we can see the so-called LDAP server, which is the physical implementation of LDAP. Literally, LDAP server is the servers on which we can implement LDAP for managing and storing identity authentication information, and we call it a directory service system. As a directory service system, LDAP server consists of a directory database and a set of data protocols. It is built up based on an open-source directory service called OpenLDAP, and the built-in directory database for LDAP server is BerkeleyDB. So all the identity authentication information for the IAM users are stored on this BerkeleyDB by default. And since the LDAP server is just a typical directory service system, naturally, the directory entries are arranged in a hierarchical tree structure as well. Each node in this tree, no matter on which hierarchy, is called an entry and has a unique distinguished name. And on the top hierarchy, the tree has a root node, which is very much like the root directory for a file system. And in general cases, the root node usually defines the domain component. For example, the countries or even continents. Below the root directory, we have organization unit, or OU in short. Here, we say that an OU can contain groups of objects, and we can specify an object with common name and user ID. And in the directory service system, an OU contains information about all user accounts within the organization unit. You can simply regard an OU as the province information for a particular country. There is an example showing the student information of George. And the DN of the lower left node looks like this. So in order to look up the relative information, we need to dive into the DC called .edu, and then CN, and then primary school, and then we can find George either by his name or his UID. So from the previous several introductions, maybe you could find out that LDAP is really similar to a traditional database with tree structure as well, right? Indeed, we can make a good analogy of them as is shown here. The domain component is similar to a database in a relational database, which is on the top layer. Below it, we say that the organization unit is similar to the set of tables in the database. The user ID is similar to the primary key in a table, and the common name is similar to the name of the unit data in the table. So when we are querying some data from MySQL, we need to specify which database and which data we are referring to. Then we can use the primary key or some other indices for selecting, which is just the same case as querying data from LDAP, right? And next, in order to use LDAP in practice, we need to do the following three aspects of identity authentication design, which are architecture design, function design, and process design. We shall introduce them one by one. Firstly, identity authentication architecture design. Here, we take Hive as an example. In the Hive authentication system, the application uses LDAP to implement authentication through Hive interfaces such as Swift service. During the authentication, the user information is compared with the information of LDAP server. Once the comparison matches, Hive can be used without any question. However, if other components are required, you need to apply for them again. Next, identity authentication function design. In IAM, we can define roles and user groups for different sub-accounts. An LDAP server just manages users by using groups and roles to better manage the attributes and permissions of users in different organizations. Here we say user groups are used to manage users in a unified manner. It allocates a certain permission to a group of users who share some similarities with each other, just like the employees from the same department usually have same common rights. Meanwhile, roles are used to assign permissions to each user individually. Each user entity has the NSRole attribute, which is used to add a role to the user. And by doing this, different users may have different authorities, like the administrator of the department usually has higher authorities than others, right? Finally, identity authentication process design. This is simple and relatively easy to understand. Take Hive as an example as well. The first step is to create a Hive super administrator who has the authority to do management jobs. Then, use LDAP server to integrate users, user groups, and roles under the supervision of the super administrator. Thirdly, Hive super administrator helps to authorize users in the LDAP server. After giving authorities, finally, different users can connect to approved services after passing the authentication via the client now. And some reasons why we need LDAP for authority storage and management are listed in this page. The first and most important reason is simplicity. Because LDAP server provides centralized user account management and storage services. Secondly, the security. LDAP server has a tree-like structure, so it is convenient to set different layers of authority. Thus, the users with low authority could not access to some secret information at all. LDAP has good logic, and it can be easily implemented into the existing big data platforms without introducing anything new and complicated.
Okay, that's all for LDAP, which is a directory service for the whole cluster. Next, in the third section, we can have a look at the SSO and the basic principles of Kerberos.